Welcome to Mr. Hamilton's Math Bites. This lesson is about factoring polynomials. So factoring. You might recall from a previous year, grade 10 especially, that we used a factoring flowchart to show us how to factor. And we're going to use that same factoring flowchart here with some slightly different examples that may be a little more applicable and a little more difficult for grade 11 here. So the first thing we do with a factoring flowchart is we go with the idea that factoring starts with common factoring. We always want to ask that first. Can we common factor? If we can, then we're going to do it. If not, then we move on. Once we move on, we're going to see if we have 2 terms, 3 terms, or 4 terms. Now let me give you some examples and we'll find out where these fit. The first example that I'll give us is 3x squared plus 18x plus 24. Well, that looks like a complex trinomial. It looks like it's in the form ax squared plus bx plus c. But what should we always do first? We should common factor. So let's do that. We take out a factor of 3 of all the terms. And that actually, the common factor of 3 comes out, and now it becomes a simple trinomial. The value in front of the x squared in the brackets is 1. So this is actually a simple trinomial example. So let's fill this in down below. Going to write that out again for us. Well, now I just need 2 terms that add to 6 and multiply to 8. Well, 2 terms that add to 6 and multiply to 8 are 2 and 4. So because it's a simple trinomial, I do not have to decompose that middle term. I can just go ahead and write this as x plus 2, x plus 4. Not 2, 4. So I've just put those factors of 2 and 4 right there, and then an x in front of them in each case. And that's all you have to do when it's a simple trinomial. Now if you look back in the top left-hand corner of your screen, you'll notice that I've again cleared that off, and I'll write us another example here. The next example that we'll do is 81x squared minus 1. 81x squared minus 1. Well, that's clearly 2 terms, and so the only way we have to factor that is if it's a difference of squares. Because 1 is the second term there, we can't common factor anything out of this. So let's go ahead and put that in our 2-term example. 81x squared minus 1. Now, if we can write it in the form a squared minus b squared, then that can be factored into a minus b times a plus b. So let's go ahead and write that out in that form. So it's that first term squared. So I'm going to write that whole first term, 9x squared. So the 9x is the a term. And then if we just have 1, well, 1 squared is 1. So that means my b term is 1. So my a term is 9x and my b term is 1. We write this as the a term minus the b term times the a term plus the b term. And we factor that difference of squares. Let's look at a third example now. If I gave you something like 3x squared plus 10x plus 8, what kind of factoring do we do here? Well, you might be inclined to think that earlier we factored out a 3 and we were able to make it a simple trinomial, so why can't we do the same here? Well, you'll notice that 3 in fact is not able to be factored out of 10 and of 8. So that's not actually something that we can factor any further by common factoring. So this is actually a complex trinomial. You go down to the equation of the complex trinomials, we have an a term, and that a term in front of the x squared is 3. So let's fill that into the example below. Now in this case, what we want to do is we want to find 2 numbers that again add to 10, but be careful, we want to find 2 numbers that multiply to 3, put a star beside that 3, and a star beside the 8. So 3 times 8, that's 24. 2 numbers that add to 10 multiply to 24. Those numbers are 4 and 6. And again, because they're added to 10, we don't need to worry about the signs, but we could, if it was a negative 10, we'd have to make them both negative, etc. But this is a positive 10, so I'm going to write this decomposing that middle term. So 3x squared, doesn't matter what one I write first, what one I write second, won't make a difference. So there, I've decomposed that 10x into 4x and 6x, and this is going to now be factored by grouping. I'm going to factor that first thing I've underlined first, and I can factor an x out of that. Now I'm going to factor the second thing I've underlined. I can factor a factor of 2 out of that. And if I've done it properly, I should end up with the same thing in each one of these sets of brackets. And that's in fact what I've done. This becomes 3x plus 4 times x plus 2. So with that last question in mind, let's look at this. 6x squared minus 3x minus 4x plus 2. Well, this is clearly not a trinomial. So the only option we're left is to try to factor it by grouping, if we can group it. And that's in fact what we just did when we dealt with the complex trinomial example. So this should be relatively straightforward now that we did the last example. Let me just write that over here. And again, I'm going to factor those first two terms and then the last two terms. Sometimes you might want to draw a dotted line between that second and third term instead of underlining it. Whatever helps you to remember to factor the first two terms, and the last two terms separately. I'm going to factor a factor of 3x. We're left with 2x minus 1. And over here I'm going to take out a negative 2. And that's going to give me positive 2x. And then it's going to change the sign in front of the positive 2 be negative, and factoring out the 2 part of that gives me a negative 1. So this becomes 2x minus 1, 3x minus 2. And we factor that by grouping. Which leaves for us one more example. And that example, you already probably know, it's got to be the perfect square. But let's talk through that anyway. Our example here will be 8x squared minus 24x plus 18. And you look at this, and if it's a perfect square, we need to have the first term, we need to be able to write that as the square root of that first term, and the last term as the square root of that. And so you might look at that and go, well, that's not a perfect square. But what do we always do first? We always begin by common factoring. And I can take a factor of 2 out of all of these terms. Now, that first term can be written as a perfect square, and that last term can be written as a perfect square. We just need to check that middle term to see if it actually works. And we check that middle term down below. I'll do that as we do the question below. Alright, I didn't actually factor that properly, did I? It's always good to check and make sure that you've done the previous line right. Should have been a 12, not a 24. Let me just change that quickly. So that makes that now something that I can check the middle term with. Is the middle term going to be 2 times a times b? That's the question we're after. Well, what's the a term? The a term is the square root of that 4x squared, which is 2x. The b term is the square root of that 9, which is just 3. 2 times 2x times 3 is in fact 12x. And because it's negative, it's going to make the sign between them negative. So we can jump right to this and say it's 2x and 3. And because this is negative, it's going to make this sign negative as well. And that's squared. That is a perfect square trinomial. And the expectation is that when we have one of those, you will use the appropriate form, not always just go to complex trinomial form. You need to be able to use difference of squares, simple trinomial, complex trinomial, and perfect square, and factoring by grouping effectively in the given cases. But you may wonder, how is this lesson any different than something I learned last year in grade 10? And so this is where we come to the challenging questions. The first of which has to do with 5x times 3x minus 1 minus 7 times 1 minus 3x. So the issue here is the fact that these look remarkably similar, but they're not the same. So what do I do in this case? Well, I hope you realize that if I take a factor of negative 1 out of this, what that's going to do is it's actually going to change the sign of both of these terms. And so that's going to make this be able to be written as 3x minus 1 rather than 1 minus 3x. So let's keep that in mind as we do this. We're going to take a factor of negative 1 out of this term. We could have also done it out of the first set of brackets too, but generally you like to have the x to be the first term in a set of brackets. Let's do this. 5x times 3x minus 1. And then if I take out the factor of negative 1, I multiply that by negative 7. That's going to make that a positive 7. And it's going to make it a negative 1 plus 3x. Switching those signs. You don't have to write it out with this line like I've done. You can skip this line if you want. But what it ultimately becomes is 3x minus 1. And now it's just a matter of factoring it by grouping. And so I get a 3x minus 1, and I'm left with a 5x plus 7. So that's one thing you got to watch out for that might be a bit of a challenge. The second type of question you need to watch out for that might be a bit of a challenge is something that works binomials into other forms. So we could call this a mixture of forms. Here we have a binomial in, well, how many terms? One term, two terms. In a two-term relation. So here we go. 16x squared minus 25x minus 4 all squared. I hope you could recognize that we can write this first term as a perfect square, and we can write the last term as a perfect square. So I can write this as 4x all squared, and I can write the second term as 5 times x minus 4 all squared as well. And so that would give me, in the first term, it would be 4x minus 5 times x minus 4. The reason I've written the square brackets is because I have round brackets inside, so it's just easier to tell them apart. But you could write round ones as well, it doesn't really matter. And the second set of brackets is going to be plus 5 times x minus 4. Now that's not it. I want to simplify it still. Don't forget to get as simplified as possible. So what this becomes is 4x minus 5x plus 20. And what this becomes is 4x plus 5x minus 20. So simplifying doesn't mean we multiply them together again. It just means we simplify within each set of brackets. This is going to become negative x plus 20, or minus 1x plus 20. And this is going to become 9x minus 20. Now, if that was difficult for you to see exactly how that worked, there's one other way to think about this question. I'll just draw this in a different color so you can see this. But what we could do instead is when we get that first line, we could try to write that as the following. 16x squared minus 25 times y squared, where we've let y equal x minus 4. Well, then it's really clear. It just becomes 4x all squared minus 5y all squared. We can do this any time in math. The only problem is if you don't substitute it back in. All right, we need to substitute back in at the end. All right, so we can go ahead and get, in the first set of brackets, we'd get 4x minus 5y. In the second set of brackets, we'd get 4x plus 5y. And then you'd have to go ahead and sub y equals x minus 4 back in. At this point, you get 4x minus 5 times x minus 4. And you get 4x plus 5 times x minus 4. And that's the same thing as we have in the third last line above. We just need to expand what's in each set of brackets. And there you go.